This is Mr. Anderson for Kellogg Community College. Today we're going to be running through the practice test for chapters 1 and 2. This is going to be just a sample of problems that could be possible to see on your test. Please understand that your test can involve any story problem or any work problem that you've done from your homework, and these are just good problems to kind of get your mind warmed up to get ready for the test for chapters 1 and 2 in intermediate algebra. Alright, so the first thing we're going to do is we're going to do a little substitution. In the first problem here, we are going to plug -2 in for A, we're going to plug 3 in for B, and we're going to plug 4 in for C. So I'm going to use parentheses here to show when I've done some substitution. And showing parentheses is probably a nice idea just from a calculation standpoint. I'm definitely making sure that I keep subtraction signs looking like subtraction signs and negatives looking like negatives, and we're going to keep going here. Alright, so in order of operations, the first thing we do is maybe think of our "please excuse my dear Aunt Sally," which is the order of operation preference. The first thing we do is any parentheses. And then, since none of these are like nested parentheses, we don't have to actually do that, so they're finished. We have a square here, and the square was located right off of that, so the exponents need to be done next. So I'll go 3 plus 4 times, this is -2 to the second power, this is going to be 4 times 4, minus 6 times -2, divided by -2 times 4. Now what we're going to do is we're going to do the multiplication and division from left to right. So 3 plus 16, and this is going to be minus 6 times 2 here, or 6 times -2, so that's going to be plus 12. And then we're going to go plus 12 divided by 2, -2 in this case, so that's going to give me -6, and then -6 times 4, which is going to be 24. So again, going from left to right, negative times negative is positive 12, divided by -2 is -6, times 4 is -6 times 4 is going to be a -24 right there. Forgot my negative. Good thing I double checked that. So I have 3 plus 16 minus 24, and this will give me an answer of -5. So one of the things that you should be careful of is, especially when typing this to the graphing calculator, make sure you put your parentheses in so there won't be any mistakes. And that was our multiplication, division, and addition, subtraction went from left to right. Now let's do the same thing for the second problem. So we're going to type in 6 times the quantity of 2 right there, divided by B, which is -3, times A, which is 4, minus, in parentheses, B, which is -3 squared, plus 4 times 4. So what you have to do here is you're going to have to do the exponents first, since there are no parentheses there, not like you would see in problem 3 to take care of. Since there are no parentheses, that we have something inside of them that can be simplified further, we move down to our exponents. So we're going to have 6 times 2 divided by -3 times 4 minus 9, and it's a positive 9 because -3 times -3 is positive 9, plus 4 times 4. And now we've taken care of our exponents. Now it's time to do our multiplication and division from left to right, and I'll kind of work on this as we go here. So we got 12 divided by -3. 12 divided by -3 is -4. -4 times 4 is -16. So there we have -16 minus 9 plus 16. And this will give us an answer, because now we're down to our addition and subtraction. -16 minus 9 plus 16 is -9. So again, it's a little complicated. These are problems that you definitely want to practice more than once, because they have a lot of computation to them. Alright, so the next two problems here, we're going to solve for x, and then we're going to do some simplifying. Now when you solve for x, the big thing, the difference between problems 3 and 4 and 5 and 6, solving for x means you have to get the answer down to x equals. And you can see that because there's an equal sign in the problem. Now what we'll do is we're going to do first some simplification by distributing using the distribution property there. So this becomes 10x minus 15 plus 7 equal to -9x plus 8x minus 12. Alright, so with that in mind, we are now going to do solving for x, and my steps here for solving for x is letters to the left, numbers to the right. But we can do still some simplification though, because 10x, negative 15, and 7, we can simplify that to a minus 8. And the negative 9x and the positive 8x is going to make a positive or negative 1x minus 12. You can show the 1 there, but in the final answer, don't ever put a 1 in front of the x as your final answer. Alright, so letters to the left, let's move that positive x over here. Because it's the inverse operation, these two simplify. This gives me 11x minus 8 equals negative 12. Move that 8 to the other side, so I'm going to add 8 to both sides. I'm going to rewrite over here just because I ran out of room. 11x is equal to negative 4. And then what we'll do is divide both sides by 11. And there's no problems getting decimals here, or fractions, and this is negative 4 elevenths. If you decided to convert this to a decimal, that's fine, but this is the most accurate answer. Alright, so problem 4, similar to problem 3, we're going to distribute first. So we're going to take the 5 and distribute that there and there. So this is 10x minus 20 equals 2, distribute that there and there, 4x plus 6 minus 4x. Now before we move letters left and move numbers right, we're going to simplify the left-hand and right-hand side of these problems. This is going to be 10x plus 17, and this is going to be 4x minus 4x, so what happens is that you actually don't have any x's anymore, and you just have 6 there. So the letters are left, the numbers we can move to the right by subtracting 17. So 10x is equal to 6 minus 17, which is, 6. Oh, hold on a second here. Did I make a mistake here? Yeah, I did actually. 3 minus 20 is negative 17. Sorry about that. So I add the 17 to both sides. 6 plus 17 is 23. Divide both sides by 10. X is equal to 23 tenths, or 2 and 3 tenths, or that would be 2.3. So any way you want to write this, 23 tenths, 2 and 3 tenths, or 2.3 is going to be fine. So the solving for x problems, you have an equal sign in them, so you have to get x equal to some answer. Now simplifying is just to simplify the problem as much as possible. So without an equal sign here, all we're doing is just trying to see if we can get this down to maybe an x and a number, like like maybe the mx plus b in a slope equation. So we're going to do some distribution here. So we're going to have 2x plus 18x minus 6 minus 8. 2x and 18x is 20x minus 6 minus 8 minus 14. So our simplified answer is 20x minus 14. And that's as simple as it can go. There's a slope and a y-intercept if you want to think of it that way. If this is a function, y equals. But for the most part, that's a simplified form. The biggest problem that most of you will run into on the day of the test is this right here. When you distribute this, a very, very, very common mistake is to go negative 15x and then forget this is a negative 3 times a negative 2, so you'll put a minus 6, but that should be a plus 6 there. That plus 6 there is very, very important right there, because most people will miss that one. So please pay attention to that problem. Everything else falls into place like a simple algebraic solving problem. Let's combine our x's, so we have negative 18x, and then negative 4 plus 6 minus 8 is going to be negative 6. Alright, so there's your answer for that problem. It's simplified down as far as we can go. Alright, now at the bottom of this page and the top of the next page are two problems that deal with your ability to remember from your previous class here, your exponential rules. Now, to make this problem probably easier for you, hold on, there we go. To make this problem easier for you, what we're going to do here is we are going to check to see how these can simplify inside the problem before we even work with this on the outside. Because in order of operations, we should deal with anything on the inside, which is inside the parentheses, before dealing with the exponents on the outside. So let's go to the inside. 12 divided by 16. Well, 12 divided by 16, that both can be simplified. 12 and 16 can both be divided by 4, so this would be 3/4. Now, there's a rule in exponential notation that if you have 7 x's on the bottom and 4 x's on the top. This means you have 3 x's on the bottom. And that's because there's 4 x's on top, 1, 2, 3, 4, and there's 7 on the bottom, 1, 2, 3, 4, 5, 6, 7, and 4 of these simplify with 4 of these, leaving 3 on the bottom. So our x's are now simplified. Now the y's are a little trickier because here there are negative exponents, so this means there's 2 in the bottom and 6 on the top. Because when we have a negative exponent, we would move that variable to its opposite numerator or denominator location. So this would become a positive y squared, and this becomes a positive y to the 6th. So they trade places, and then you have 6 on top, 2 on the bottom, that leaves 4. So now this whole thing is raised to the 4th power. Now on your calculator, if you're trying to figure out 3 to the 4th power, you would type in 3 caret 4. And 3 caret 4 isn't 12. 3 to the 4th power is 81. And this is 81 y to the 16. This isn't, this is 4 times 4, not 4 plus 4. And the reason why it's 4 times 4, it's saying I have 4 of the y4s. So it's y4, 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 which is y to the 16. Same thing down here if you're trying to find 4 to the 4th power, because everything gets written to the 4th power. This would be 4 caret 4, and that would be 4 to the 4th power, which is 256. Calculator helps there. And since there are 4 of these x cubes, it would be x cubed, x cubed, x cubed, x cubed, or x to the 12th power. This is definitely a lot of students will struggle with this, trying to remember those rules from Math 101, so you'll want to go back to that chapter in the book to review these materials. There's some rules there in the homework, and also there's a walkthrough on the video that I've made for that section. Alright, so problem number 8, it's kind of like the same thing. The first thing we do is simplify 15 halves. Both can be divided by 3, so this becomes 5 thirds. So there's my 5 thirds right there. 9 minus 7 is 2, so we have 2 x's left. These y's change positions. And then if we have 2 on top and 4 on the bottom, 2 simplify out to make 2 on the bottom. Because here we have 2 y's on top, 4 y's on bottom. Cross out 2 y's here and 2 y's here, leaving me with 2 on the bottom. Now, what's weird about this negative 2 there, now I'm still putting that over here. What's weird about that negative 2 is this whole thing gets flipped on its head. This goes 3y squared over 5x squared. But now instead of me writing this as a negative 2, I'm going to write it as a positive 2. And then we square everything on the inside. 3 squared is 9. 2 times 2 is 4. And down here, 5 squared is 25. And then 2 times 2 is 4. And there's really a lot to go in depth with this problem because there's a lot of rules about exponential notation. But I encourage you to go back to your your work in chapter 1 and check those notes. All right, moving on down to, hold on a second here. Problems 9 and 10, all we're doing is isolating a variable. We'll be spending a lot of time doing this in other sections of the book, but this is kind of like your baseline stuff. We're going to try to get z all by itself here. And to get z by itself, we're just going to move the xy to the other side. So let's move the xy. Alright, so we get negative xz is equal to w minus xy. And the z is now almost by itself. We're going to divide both sides by negative x. So now the z is simplified down to itself, 1z, or just the z. That's the best way to write it. And now we have w minus xy divided by x. And that really is a simplified form. You can break this down even further if you want to split this monomial up between these two numbers and then do some simplifications of the x's on one of them. This is as far as you can go. But if you wanted to take this to an A plus level, you would have a negative w over x because you would have w divided by negative x, and then this would be positive y, and it'd be positive y because negative x divided by negative x is a positive 1. So this is an alternative answer, but this one is acceptable for the first exam. Now here, to solve for x, you'll notice I have 2 of them. So there's a trick you can do. You can pull out or factor out an x and get the y minus z is equal to w. And then if you divide both sides by y minus z, what you get is x is equal to, because these simplify to 1, w over y minus z. And that can't be further simplified. This is a binomial in the denominator, so like the original, this problem above it, number 9, I could split that up because it was a monomial. You cannot split this up because that's illegal to do with a binomial. One of the problems on the test is going to have you do an absolute value problem. And I want to show you two ways to do this, one with the graphing calculator and one without. First of all, let's go without the graphing calculator and see what this looks like. What you will do is you'll plug you'll plug the values of this in for x and then solve the problem. So here if you type in -2 in for x, so the absolute value of 2 plus 3, absolute value of -2 plus 3 is the same thing as saying 2 plus 3, so your answer is 5. The absolute value of -1 plus 3 is the same thing as saying 1 plus 3, so the answer is 4. And the absolute value of 0 is 0. The absolute value takes the positive distance of all these things, so that is going to be just 3, 0 plus 3. But when we start to go now to 1 and 2, it's going to be the same answers as this over here, because absolute value of 1 plus 3 is going to be 4, because the absolute value of 1 is 1, and the absolute value of 2 is 2, plus 3 is 5. So we have 5, 4, 3, 4, 5. So this is what the graph looks like. -2 is going to be plotted up at 5. So -2, 1, 2, 3, 4, 5. -1, 1, 2, 3, 4. 0, 1, 2, 3. Whoops, I wrote that a little too low there. And then we go back up to 4 and 5, and we get this V shape. This is not a parabola, this is an absolute value graph. Another way to do this, and when I click on this, when I click off this to turn on my graphing calculator, you will see this go away. So the graphing calculator, you can type this in by going to the y equals and clicking on the math button. Now there's a function called number there. Click to the right for number and hit enter. So this is your absolute value function of x. Click underneath the mode key for x and close it off, and then go plus 3. And then hit graph, and you'll see that you get your V there. Now that of course is good if you want to go to your table. Second graph will let you do that, and so you can see the table -5 or 5, 4, 3, 4, 5. You can see that by doing those steps. So let's review that one more time. Go to your y equals, click math, right, enter. Then type the x, and then close it off with the parenthesis above the 9 key. Then go plus 3, because that's what it says in the worksheet. Then go to your graph to make sure it looks like a V. And then to see the points that you plug into your table, go second graph. And then you can scroll up using the up arrow key to see this 5, 4, 3, 4, 5. Okay, so that takes us, let me move the calculator out of the way then. Whoops. Let me move the calculator out of the way then. And let's go back to the last 3 problems here, which I will do to end this first part of the video. Alright, so it says at the beginning of 2005, CardShark had already received 600,000 cards at their website. At the beginning of 2009, that number had climbed to 1,400,000 cards. Calculate the rate at which the number of hits is increasing. Alright, so in this case, instead of hits, it would be cards. Sorry for the little typo there. But so what we're talking about here is we're trying to find, when I say rate, we're trying to find a slope. And slope is y minus y over x minus x. So what we have here is 2 years, and we also have a we have 2 years, and we also have 2 numbers of cards. There's a couple different ways you can do this. You can type in the years if you want to, like you can say 2005, comma 650,000 cards. And we can have also 2009 and 1,400,000 cards. Alright, so what we're going to do here is we're going to then subtract the y's, like y minus y, and subtract the x's, x minus x. So this is going to be 1,400,000. I'm going to choose to go in that order, divided by 650,000. Oh shoot, nope, sorry about that. Crap. 1,400,000 minus 650,000, caught me sleeping there, And then down below we're going to have 2000, this is 2009 minus 2005. So what this gives me in the numerator and the denominator, you're going to compute these out, and when you get to your final answer, because the denominator is going to be 4 and the numerator, I didn't work this out ahead of time, but the numerator is going to be a big number. Use your calculator to simplify this problem, and what's going to happen is that you're going to get a whole number, 187,500 cards per year. Now, the cards is what we're talking about at the top, and the year is what we're talking about in the bottom. So having a nice label for that's pretty nice. Do not put it over 1. I know this is a big number over 4, but when you divide the two numbers, you get a whole number, and you would not leave something unsimplified. So this is the answer I'm looking for there. So y minus y, those are your card values, and x minus x, those are your year values, keeping the order the same. Alright, the final part that we're going to do today is we're going to do this, no, at least the final part of this video is we're going to talk about these two pieces that were in section 2 of your book and homework. So you're going to have one of these graphs here. So it says here, find 4 parts, f of 1, then the domain, any x values for which f of x is equal to 2, and then the range. And so I'm going to do that for each of these problems. So f of 1 is really asking if x is equal to 1, where is that? So I'm going to put my little pen here at x equals 1, and I'm going to see where the line is. And the line's right there. So there's my part A of the problem right there. And so my answer for f of 1 is -4. That's my y value when x is equal to 1. Now we're going to look at my domain. If I put my finger on the left side here, the furthest most left point, or left part of this line, is at -4. So let's put x inside our set notation here, and we're going to have -4 on the left. All the way on the right is going to be 1, 2, 3, 4, 5. So we're going to put that on the right there. If I move my finger all the way to the right, our furthest right value for my domain is 5. And x is going to be in between -4 and 5 because this is a continuous function. I don't have to lift up my pen or pencil to get from the left to the right side. Okay, so here's another part. This is an open circle, so that's going to be a less than symbol because x is actually not going to get to -4. But this is going to be less than or equal to because it's going to actually get to the 5. Now, to find f of x equals 2, or for part C, find any x values for which f of x is equal to 2, what we're going to do is we're going to look when y is equal to 2. So I'm going to make a line that goes across at 2 there, and see where my x value is. And it looks like my x value is right there. So at f of x is equal to 2, my x value, 1, 2, 3, 4, is 4. So my answer here is going to be f of 4 is equal to 2. See, so the question is asking when y is equal to 2, what is my x? And I've solved for that right there. And there's the notation for you. Now the range. Now, it's kind of difficult for range because instead of moving from the left to the right of the graph, we're moving from the lowest to the highest point. The lowest point on the graph is way down here, and that's at -6. So let's set my set notation up. So -6 is as low as this line goes, and the highest this line goes is 1, 2, 3, 4. So this y goes from -6 to 4 continuously, and since both this on the left is a black dot all the way at the bottom, and this on the right is a black dot all the way at the top, then these get less than or equal to signs because the function actually exists at -6 and it exists at 4 for my range. Alright, let's move over here. Slightly different picture, a little bit trickier in some ways and easier in others. So f of 1, so what I'm going to do is go where 1 is on my x and go see where that is on my y. That's way up there, so my f of 1 is equal to 5. Then my x room, or my x set notation, from the left is -3. All the way to the right is 1, 2, 3, 4, 5. So -3 to 5, my x is continuous, but since that 5 is an open circle, it does not get less than or equal to, but this gets equal to symbol because x will eventually get to -3. So let's look at f of x equals 2. So I'm going to make a line here at 2. So 1, 2, make a line. And it looks like it hits right there at this dot. So f, by coincidence, it's 4 equals 2. So my x value is 4 when my y value is 2. And finally, we're going to go to the my y value here, my y, such that, let's look at the lowest spot on my chart here. My lowest spot is going to be right there at that open circle. So that lowest spot on my y value is 0. So y is going to go from 0 all the way to its highest spot, which is at that dot there at 5. That's my range. So this graph is no higher than 5 and no lower than 0. But look at the blue dot and the open circle. Y will never get to 0 because the line will stop before there. And y will get to 5 because there is a blue solid dot at that spot. And that is going to be my set notation for, or I think I've been saying set notation. I could be misspeaking that and mean interval notation. But this is the notation that's right there for the problem. Well, this covers the first 2 pages of the practice test. We've got more to cover in parts 2 and 3 of this video. So thank you for watching.